Okay, so maybe I start one to warm up and hopefully. So maybe one question to maybe start with David. So I guess it's interesting you were trying to do that study on continuous learning with that continuous fine-tuning of the various kind of knowledge and different domain and trying to see if they remember or forget about the stuff. But the classical argument or classical kind of question regarding this is really fine-tuning the optimal way compared with the other one, you know, the retrieval augmented generation, right? So for example, if you have the whole knowledge of security, do you really want to fine-tuning on security, or you just want to look up that knowledge later on? Let's say if you have new code, do I have a similar kind of, you know, buggy code as I see in the past? So what are your thoughts on that?
Yes, I think that's a very interesting point, right? I think we only look into fine-tuning, which is the traditional fine-tuning, basically fine-tune all the parameters. Even now, there is more advanced methods, like, for example, one you mentioned, there's also parameter-efficient fine-tuning. So we don't really know what is the impact of that, right, when dealing with the new data coming in. So one thing with the retrieval augmented method is that you need old data. And sometimes when the APIs are new, basically there is no old data in the past that we can refer to. So I think there is a lot of unknowns. The field moved very fast, right? So in the past, it's just fine-tuning everything. Now people are proposing new methods. So what exactly are the limitations when these new methods are being introduced? I think that's subject to very exciting study. I think in my opinion, it will be another exciting decade, just like the decade that Satish mentioned earlier.
Okay. Since there's no questions, so maybe let me ask another question going to the next one. So Romain, so I think you make the conclusion saying we cannot really kind of do that because they don't understand the structured information for the code. But again, that's basically the simple way we're cramming source code as it is to these kind of large, neural networks, right? But if you see the talk from Lingming or maybe tomorrow Bashak Array, so we're kind of now entering this whole age of multimodal, right? So in other words, when we train the code, we can also kind of combine that with additional meta information like IR, or maybe coverage, or maybe AST and so on. Do you think if we combine these additional information while we're training the neural network, would they actually better answer that question, or what are your thoughts on that?
Yeah, so absolutely. So basically, what we see here is that the best model, so the one that is performing best overall, is graph code BERT, and that's a model that is trained to predict like the data flow between variables. So it is using this source code knowledge, and even if it's not always amazing, it is doing much better than a bunch of other models that use more simpler like NLP objectives. So there is really, I think that's one of the conclusions of the study, which is that if we have these pre-training objectives that do more to model code as code, then we are going to do better on these kind of tasks. We are going to be able to model better code, and we should be able to test it.
So there's some question at the back.
Hello, thank you for the wonderful presentations today. My question is, I think, targeted mostly towards Dennis, and it's specifically to do with previous work that was done, for example, correlating developer attention with language model attention and looking how well they fit together. Since these studies, when they were performed, they were mostly done in a correlation framework. Is there an implicit call to redo some of the previous studies, but redo them in a causal framework instead?
Absolutely, and not only those studies, but many others as well.
Hi, Kripal from University of Alberta. So I have a question for Emad. So for the hallucinated packages, were any of them actually hallucinated multiple times, or was it always a completely different package?
Yeah, thanks. So there were not very many such cases anyway, and I believe they were only, they were unique. But there weren't very many that were hallucinated in the first place.
Hi, Masa from Kyushu University. I have a question to Dennis. You told us that confounding factor is very important. And yeah, I may not fully understand the causal effect relationships, but I think it's very difficult to list it up or confounding factor because software engineering tasks have a lot of confounding factor. So how do we deal with like confounding factors and extract good insight or something in the research?
Well, we have a lot of domain-specific expertise, right? So this is where our software engineering knowledge comes in, right? So we have a lot of evidence from the literature. We have a lot of metrics that we can compute. A lot of features that we can engineer and compute. So essentially, this is the work that we have to do, right? We have to map it out and essentially use, yeah.
This is a follow-up to Dennis. Is the confounding factor something that we need to worry about when we are saying that something is useful, rather than if we find that something is not useful, then is it enough that in that case it's not useful, so therefore, I mean, is it important in proving that something is good, but not so important in finding out that something was not good?
That's a good question. It depends on the use case. It depends on the objective, right, and what you're trying to do with that. I think we had a previous discussion with Satish at some point where he was pointing out that a lot of work that we do right now in the era of applying large language models for code, we need to do a lot of experimentation, right? And for example, we came from Shonan meeting, right? And I don't know, lots of discussions were focused on prompt engineering, how to do prompt engineering, right? So this is a prime target for this type of analysis, right? How much all those different confounding factors impact the way we do prompt engineering in the current context. So, to answer your question precisely, we need to think a little bit more on the objectives, right, and what you're trying to do with that information, right?
Sorry, I had the mic.
Okay.
So I guess it's a question for all the speakers, maybe even folks in the audience. So, there's this new models, the Phi model for Microsoft, right, which they really focus on flipping it around, where they actually say, okay, what are basic principles that we need to know when you want to code? And then let's create data, synthetic data from there, and then let's teach a model, right? Now, especially when I think of Dennis's work and Romain's work, you kind of are going the other way around, right? So you say, okay, we build a model. I want to understand if the model has that knowledge. But do you think maybe a way where you can actually turn the other way around and build a model from day one that it has that knowledge? So what are your thoughts on that? And what are your thoughts basically about, I guess my excitement about these small models is it's very expensive to deploy large language models to actually in people's IDEs where you have thousands of developers. So we really need to figure a way to make these models smaller.
Yeah. So one thing that we know is that the more domain-specific data, the more domain-specific knowledge, you can embed in the model, the smaller a model you can get away with. So we can have these huge generalist models, but if we can find a way to really efficiently encode a large amount of domain-specific knowledge, then I don't see why an approach such as, you know, like a model as small as 5, for instance, could work pretty well. So yeah, and I mean, I can think of, you know, older papers where, you know, where we had, you know, these graph neural networks and so on, where they would show, look, this model has like, I don't know, like 10 million parameters, and it does better than this, you know, older model that has like, I don't know, 60 million parameters, this kind of thing. So I think that's one of the ways to go, absolutely.
So I just want to quickly jump and say what you said exactly is one of the main use cases for segregating some of these measurements that we're currently using for measuring accuracy, right? So like in our case, we were trying to measure how well the models are doing in the context of different AST-based constructs, so programming language constructs that you're defining. And armed with that knowledge, you can actually go back and say, well, I don't have enough training data probably for this programming concept or for that programming concept. Then you can actually go and enrich your model and retrain your model with that information, since you know where your model is not doing well, weak points.
Hi.
So maybe I also may add something like, I think like those large models has a lot of knowledge there, but sometimes for a specific task, we don't really need all those knowledge there. So I think in a prior work and also upcoming work will be presented in the next 2 weeks, we show that we have a big model, we can compress it to 1% the size, and the performance in terms of speed, accuracy, and also in terms of energy can be reduced by a huge amount for that particular task. So I think the model that huge may not really be necessary, and there is, I think, a need for us to retrain in what way we can learn a smaller model that can do better for a specific task. And in terms also like synthetic data generation, sometimes the problem is this, the synthetic data generation may have certain properties in generating synthetic data. And sometimes the large language model will learn those properties that are not meant to be learned. And then those may actually confuse the model. So we had an experience before in trying to be able to let the model learn from the binary representation of methods that have multiple parameters. So we know that many methods have just 1 parameter, 0 parameter, 2 parameter. How many methods have 7 parameters? The data is not enough. So we automatically generate those data, but it actually confuses the model. So I think the art of generating synthetic data that can help to improve the accuracy of the model is also a very interesting direction to look at.
Hi. So my name is Clara from Monash University, Australia. First of all, I feel really great to hear the talk around the explainability for the code model, that kind of thing. So I have been working in this area for a while, and one question that often that is quite challenging for me is that how do we know what is the right explanation? So I just want to hear your comment around this question as well. And with the age of the LLM, the model is getting bigger and bigger. How can we, and we cannot access that kind of model as well. How can we really explain them? Yeah, 2 questions. Yeah, thank you.
That's a really difficult one, because here you actually need to do user studies, human evaluations, right? You really need to understand what developers perceive as trustworthy explanations, because that's your goal, right? How do you provide explanations where you can build trust between developers and models, right? And of course, you can formulate all sorts of hypotheses. And if you're asking me to formulate hypotheses on the spot, I'm not going to do that. I need to think about that. But my suggestion would be we actually need to design. We need to design user studies to do, and then bring up the machinery up to speed to cover it. Did that answer your question?
Yep, thank you. Yeah, and what about the explainability in the age of the ChatGPT, LLM, that kind of thing? Yeah. Maybe others can answer as well. Yeah, anything is okay. Yeah.
Maybe I just give some comments, like just at Sainer, just I think happening like 2 weeks ago. So my student was presenting a work. So basically we want to see if ChatGPT can explain to help junior developers in debugging. So we don't really know what is a good explanation. So as Dennis mentioned, actually we do the user study. So we ask a lot of people like, hey, there is this bug here, how you explain? And then we actually ask the person to create something like a chain of thought explanation. And then we measure to what extent ChatGPT can generate that. So we created a benchmark for that, just for that one task debugging. But I think as also like mentioned many times in this event and also in the Shonan meeting, we need more benchmarks. So if we have more benchmarks, exactly how human will appreciate this LLM, so what kind of explanation they need. And I think this can help us to build the next LLM that can generate the explanation that human really need for them to use a particular tool.
So just something very quickly to add. The main motivation of our work was to go from the token level explanations to concept level explanations. And we are maybe halfway there, because right now the work that you've seen primarily is based either on abstract syntax tree-based concepts or programming concepts, which are based on the taxonomy that we define. But this is halfway there. We want to get to the concept levels. As far as how to formulate that information back to the developer, this is where user studies come in. But we are slowly moving machinery towards the concept level from token level, which is obviously not useful.
Okay, so unfortunately I have to close this because it's dinner time. So again, thanks all the speakers for their wonderful talk and discussion.